Right, in this one I'm going to be talking about the marginal product of our two factors of production, capital and labour. So we have our function here where y is output. You can see a function of capital and labour. So we've got a Cobb-Douglas production function where we've got our two factor inputs, and we've got A, which is total factor productivity, but for the purposes of this video, just think of it as some constant. The two exponents are numbers between 0 and 1. They sum to 1, right? You got alpha, you got 1 minus alpha, sums to 1, which gives us constant returns to scale, but that's sort of beyond the scope of this video. Just think of, for example, think of alpha as 1/3, and then so 1 minus alpha would be 2/3, for example. So if you have an exponent between 0 and 1, then you have a concave function like this. So this is output as a function of labour. So we're holding capital constant here in this example. We've got a concave function. So it says as we increase our labour input, what happens to output? And you can see that it's an increasing function, right? So as we add units of labour, output goes up, but at a decreasing rate. So for example, if you go from like 1 unit of labour to 2, right, go from 1 worker, so if I can draw the corresponding points on the y-axis here. So if you go from 1 unit of labour to 2, you can see the output jumps up by quite a lot. But over here, you know, if you go from 5 workers to 6 workers, right, I appreciate that these lines aren't very well drawn. Please be charitable in your interpretation of this drawing, but you can see that if you go from 5 workers to 6, for example, you still get more output, but less than, you know, from 1 to 2. So like that 6th worker adds less productivity than the 2nd worker, and each additional unit of labour, you know, is going to add output but less than the one before it. So like the marginal worker is always going to be less productive than the one before it, and you can see that here, right? This says if you hold all else constant, so you hold capital constant, how does output change as we change our labour input? And you can look at the steps here that I've taken to take the derivative, but you end up with this. And you can see here that marginal product of labour is a function of all this. As if we hold everything constant and we increase labour, what happens? Well, this here inside the parentheses gets smaller as we increase labour, right? Because labour is in the denominator. So this remains positive always, but it gets smaller and smaller and smaller as we increase labour. And that's shown here if you plot marginal product of labour as a function of labour. So this is just the first derivative of this. You can see that as we increase labour, the marginal product of labour gets smaller and smaller and smaller and smaller, always positive. So this is asymptotic to the x-axis. but it's always diminishing, diminishing, diminishing. However, if we say we choose some labour input, like here, for example, yeah, and we hold that constant for a moment, what happens if we then increase capital, right? Well, at that point, if we increase our capital input, then this number here inside the parenthesis gets bigger, so our marginal product of labour increases, right? So we get some higher corresponding point on the y-axis here. And so basically what happens is that if you increase capital, that's not very well drawn, so I'm going to draw that a bit better, but you get my point. As we increase capital, labour becomes more productive, and vice versa. You know, if this was, if we'd plotted instead marginal product of capital as a function of k, and we had some number of machines, right, some value for our capital input, if we were then to increase labour, our capital would become more productive, and that is what we call capital and labour being complementary in production. So say, for example, you have a firm that has 10 workers, but between those 10 workers, they only have 2 machines. If you then increase your capital input, so say you add another 3 machines, or hell, you add another 8 machines, so there's now 10 machines, so each worker has a machine each, then your labour becomes more productive, right? Each of those workers is going to become more productive. Those 8 workers now have a machine each. Just to give a very simple example, so more capital makes your labour more productive, more labour makes your capital more productive. And yeah, that's what we call capital and labour being complementary in production.